first YouTube video. We are going to weld a urethane belt on a 1943 South Bend Heavy 10 or 10L tool room lathe. I'm going to use a urethane belt instead of the serpentine belt. Here it is. It feels like a combination of plastic and rubber. A lot of people are using serpentine belts, and there's a thread on Practical Machinist that inspired me to use a urethane belt instead. So I've already welded it on once, and I made it too long and the spindle slips. So I had to cut it apart, and I'm going to redo it, and hopefully I'll be able to get more tension on it. According to the thread in Practical Machinist, the serpentine belt has cord in it, which doesn't allow it to stretch, and this does not, so it stretches a lot more. So I'm going to be using a jig that I made to weld the belt. It's just a couple pieces of scrap aluminum. I drilled and tapped it to accept these screws, and it has these springs in it to hold it together to force the belt together. It works pretty good. I only used a drill press and a hand drill and a couple taps to build it. It's nothing special. Anybody could build this as long as they had a drill press. So it's already worked good twice. Once to weld the belt, once on a test piece, and I'm happy with it. I'm also going to apologize in advance because this will probably take a fair amount of fiddling to get it all lined up properly, and I'm not sure that I can edit the video, so you might have to simply just fast forward over this part. So I'm going to take set this piece in here, clamp it with just a little bit sticking out. Go. Looks like about 1/4 of an inch sticking out of the inside of the jig is about what you want. That's going to give you enough room to get in there with a heat gun, and it'll be close enough so the belt doesn't distort when you push it together when the ends are hot. Tighten this down. It moved. So we'll readjust, square it up, clamp it. There you go. That's about what we need. And now we're going to do the same thing with the bottom piece. Might be tough because the belt is now shorter, therefore there is less play in it. There we go. Maybe we can scooch it to a smaller pulley. That helps a lot right there. Alright. Gives us the extra added slack we need. go. Tighten the bottom one up. Alright, so check this for alignment and it looks pretty good. Now, more important I've found than the exact gap between the two belts is the alignment side to side. You don't want the belt offset like that. That's just going to create tracking problems and possibly not let it go around the pulley nicely. So that looks pretty good right there. So that's what you want to end up with before you weld it. And you pull this down and it will spring back, and that's what's going to jam it together once it's liquid, or at least sticky. So now we have a $10 heat gun from Harbor Freight, which works mint, doesn't cost a lot, and for this project at least, I'm very happy with it. So we're going to take the bottom belt, drag it down, and heat up both ends of the belt, and then let it go, let it squish together, and it will weld. And the general difference between welding and adhesion is a welding is a melding of the two base materials, where an adhesion is like glue. It's just sticking to something else without combining with it. So this is a weld, not an adhesion. The serpentine belt method for this uses an adhesion. It's basically, from what I gather, super glue. Alright, so we're going to weld this and see what we can screw up. That's it. You want to melt it until the edges kind of roll over and sort of expand a little bit, but you don't really want them to start bubbling and turning black or anything. And press it together, and there you go. That should be welded. I really doubt that you could pull that apart. So we'll just let it cool for a minute or so, and we'll take the jig off, and then we will grind the edges and the backside. You need to grind the backside because you don't want it making a skip as it goes over the pulleys. And same thing on the edges. You don't want to cause tracking problems with the bubble sticking out the edge. The top surface, it doesn't matter because it doesn't touch anything as it goes around the pulleys. And you can just leave that as is and it'll work fine. Go, and that's what it should look like. This one is misaligned a little bit by maybe 20 thousandths, but I don't think it's going to be the end of the world. So I have a drill with just a common piece of a drum sander on the end. This works pretty good. You could also use a I was going to use a an air-powered grinder, an angle grinder, but that would be kind of loud, so I decided not to. So you kind of just twist this around and just grind the backside off. Nice and flat-ish. Looks pretty straight. That looks decent at least. And there you go. So what, the whole thing took, what, 10 minutes? Not bad. Now you can put her on the pulley. And we will start the machine up and see what it does. Tighten the belt. That's going to need some more tightening. Alright, so here we go. That works pretty good, actually. It starts up. Yesterday it was hesitating to start with a little spin by hand from the chuck. Right there it started up, no problem at all. So I think I've attained my goal here. So like I said, this is all explained on Practical Machinist, the machining forum. You can go look up that that thread, and there's an attachment in it. The guy has a website. It was actually very helpful in giving me a clue as to how to do this. But I figured I'd make a video just so people could, see the process. A lot of people on the thread seemed interested in hearing about it and how well it works and the drawbacks, etc., etc., etc. So, go check out the thread. It's also pretty cool. Thanks for watching.